Rest assured, sound will travel a little faster in a warm day than a cold day. And let me give you some evidence of that. It's something that occurred to me when I was a kid. I couldn't figure it out. And later on, when I got into physics, boom, the answer to my question came. When I was a kid, I used to be a Boy Scout. And we used to go camping up at Camp Nye in Saugus, Massachusetts. And we'd camp on one side of the lake. This is a lake. And there'd be another scout troop over here. And we'd have our tent set up here. And we'd tent out here, you know. There's our troop here. Here's that troop over here. They've got their tents. Okay. In the daytime, you could yell over to these guys, hey, you guys, how you doing? And they say, speak a little louder, I can't hear you. How you doing? Fine, how you doing? Oh, okay. How's it going? Oh, you know how these heavy conversations you have, yeah? But it turns out we could just barely hear each other. But at nighttime, you could hear these guys whispering in the tents. You could hear them so clearly. I can remember that, and I wonder, wow, at nighttime I can hear those guys. How come I can hear them so good at nighttime? In daytime I can't. And I didn't know the answer to that. And it took me a long time to find the answer to that. Has anyone ever experienced something like that? It's not all the time true, but under special conditions, sometimes you can hear a lot clearer over a long distance than other times. Let me tell you what happened, okay? It turns out that over here, let's suppose over here, someone says, hello, how are you? And we get sound waves coming off like this. And the sound keeps going. Now, it turns out the direction of sound will always be at right angles to the waves. So, for example, like this, it's like that. And up here, it's right angle, right angle, right angle. See that? So when all the air has the same temperature, then the sound will travel at equal speeds in all directions and form all these circles, yeah? But how about in the case where maybe at nighttime it's relatively cool above the water and relatively warm up above, a so-called temperature inversion? When that happens, how about this wave? Will this wave get to here, or will it be further along? In the warm air, it will get to here. In the cold air, it would get to here. And up here, maybe up to here. So you know what's going to happen to the wave, gang? The wave is going to be bent more like that. And when it gets over here like this. Now, my rays, being perpendicular, up here, ooh, look at that. See that? Okay. So what you're doing is you're getting more energy in the air at nighttime than you are in the day, because the sound is being bent. The waves are being bent. We don't say waves bend because one part's going faster than another. We have a name for that. What's it called, gang? Refraction.